Question 6 concerns a cable car system used to transport people up a hill. We have a diagram of the stationary cable car suspended from a steel cable with cross-sectional area 2.5 times 10 to the minus 3 square meters. In A, we have a graph of load in 10 to the 5 newtons against extension in 10 to the minus 3 meters. In part 1, we need to draw a line of best fit on the graph. For part 2, we need to use the graph to find the initial gradient k for this sample of the cable. Well, the gradient, we can take this triangle here, and it's the change in y of 2.55 times 10 to the 5 newtons over the change in x of 5.0 times 10 to the minus 3 meters, which comes out at 5.1 times 10 to the 7 newton meters to the minus 1. In B, the cable breaks when the extension reaches 7 millimeters. We need to find the breaking stress, giving an appropriate unit. Well, stress is force over area, and from the graph at 7 millimeters extension, we have a force of 2.8 times 10 to the 5 newtons. The area of the cable was given in the question. This comes out at 1.1 times 10 to the 8 newton meter to the minus 2. For C, in a cable car system, a 1,000 meter length of cable is used. We need to find the extension of the cable when the tension is 150 kilonewtons. Well, force is constant times change in length, and so the change in length is the force over the constant, which is a force of 150 kilonewtons, the constant we found previously. This comes out at 2.9 times 10 to the minus 3 meters. That is for 10 meter sample, so if we multiply this by 100, we get an extension of 0.29 meters for 1,000 meters of cable.